Hello everyone. Today, we're going to learn about higher order derivatives. First, we need to know about the chain rule, which has the formula of if h of x is equals to f times g of x, then h prime of x is equals to f prime times g of x multiplied by g prime of x. So first, let's have an example for the chain rule, which is f of x is equals to times the quantity of 5x to the power raised to the power of 4 minus 6x plus 8 raised to the power of 5. Now we're going to write the process as f prime of x is equals to 5, which we will move the 5 outside, and times the quantity of 5x raised to the power of 4 minus 6x plus 8, which we will just copy raised to the power of 4. Kasi 5 minus 1 is equals to 4. So we will subtract the 5 to 1. We will subtract 1 to the 5 to the 5th power, which will become 4. And now we will get the derivative of the 5x raised to the power of 4 minus 6x plus 8, which will then become 20x cubed minus 6. Since 5x raised to the power of 4 is equals to 20, which is 5 times 4, then 4 minus 1 is equals to 3, then 6x has the derivative of 6, and 8 has the derivative of 0, which will then become the answer of f of x is equals to the quantity of 100 cubed minus 30 times the quantity of which we will copy the 5x raised to the power of 4 minus 6x plus 8. There are 6 rules under higher order derivatives. But first, let's have a few examples that all of the rules are applied before we break it all down. For the first example, we have find the derivatives of y is equals to 7x raised to the power of 4 plus 9x cubed minus 5x squared plus 10. We'll use the prime notation, which is y prime, because it did not specify that we need to substitute the x. Now, we'll write the process as y prime is equals to 20x cubed plus 27x squared minus 10x, because we got it from the 7x raised to the power of 4 plus 9x cubed minus 5x squared. Since, like what I said in the chain rule, we have 28 for the 7x times 4, then 4 minus 1 is equals to 3 plus 9x cubed is equals to 9 times 3, then 27, then the cube will get minus to the 1, which will become 2, then minus 10x because 5x squared is equals to 10, and then the plus 10 is equals to 0. Then the next one we will write down y prime is equals to 84x x cubed plus 54x minus 10. Now, we'll multiply it again and again until we get to the final answer, until we get 0. Next to the process is we'll write it as y prime is equals to 168x plus 54, since we got the derivative of 84x squared plus 54, then we won't write 10 because it's equivalent to 0. Then we get the final answer, which is 168, because we got the derivative of 168x, which will remove the x only, and 54 is equivalent to 0, just like I previously stated. The second example is find the third derivative of 3x cubed plus 10x squared minus 5. So just like the first example, we'll get the derivative of 3x cubed plus 10x squared minus 5. Now, we're going to write the process as y prime equals 9x squared plus 20x because we multiplied the 3 times 3 in the equation, which will we get then 9x squared because 3 minus 1 is equals to 2 plus 20x because of 10x squared. Now we'll get the derivatives again, which is then y prime is equals to 18x plus 20. Now we'll get to the final answer, which is y prime is equals to 18. For the third example, we have find the f prime of 3 of f of x is equals to 3x cubed plus 7x squared minus 4. Now we'll be using substitution. As you can see, we will substitute 3 to all of the x in the second derivative, as it is said that find the f prime of 3. So we'll write it as f prime of x is equals to 9x raised to the power of 2 plus 14x. But first, we'll get the derivatives of the equation. Now, we'll get f prime of x is equals to 18x plus 14. Now that there is a variable next to 18, we can now substitute 3, then multiply it to 18. And when we find the answer, we can just add it to 14. And that's how you get the final answer. To illustrate it, we'll have it as f prime of 3 is equals to 18 times 3 plus 14 is equals to 54 plus 14, and we'll get the final answer as 68.
Now moving to the 7 rules of higher order derivatives. For the first rule, we have the constants rule. If f of x equals c, where c is a constant, then f prime of x is equals to 0. It just means that if there is no variable with the constant, then the answer is just 0. For example, for number 1, we have f of x is equals to 9. Now f prime of x is equals to 0. Let's have another example. If f of x is equals to 5, then the answer is still 0 as there is no variable. Let's write it as f prime of x is equals to 0.
The second rule is the power rule. So if f of x is equals to x to the power of n, where n is the element of n, then f of x is equals to nx to the power of n minus 1. Let's have an example. For the first example, we have f of x is equals to 9. We're going to write the answer as prime of x is equals to 9x raised to the power of 9 minus 1. Then f prime of x is equals to 9x raised to the power of 8. Another example is f of x is equals to y raised to the power of 5. Let's repeat the process. Let's write it as f prime of x is equals to fy raised to the power of 5 minus 1. Then the answer will be f of prime is equals to fy raised to the power of 4.
For the third rule, we have the constant multiple rule, where we are going to multiply the constant to the power and subtract 1 to the power. This is like the first two rules. It is just combined. If f of x is equal to kh of x, where k is a constant, then f prime of x is equals to kh prime of x. An example of this is f of x is equal 5x cubed. Then we'll write the process of f prime of x is equal to 5 times 3x cubed minus 1. Then the answer will be f prime of x is equal to 15x squared.
The fourth rule is the sum rule. We are just going to add two constant multiple equations. If f of x multiplied by g of x plus h of x, where g and h are differentiable functions, prime of x is equals to g prime of x plus h prime of x. For example, f of x is equals to x raised to the power of 5 plus x squared. To know the process, we're going to write as if f prime of x is equal to x raised to the power of 5 minus 1 plus 2x squared minus 1. Then the answers will be f prime of x is equal to 5x raised to the power of 4 plus 2x.
For the fifth rule, we have the product rule. D over dx times the quantity of f of x multiplied by g of x is equals to f of x times g of x plus g of x times f of x. For example, one example is f of x is equals to the quantity of 3x plus 5 times quantity of 4x squared minus 3. The first step of getting answer is substituting the equation to the formula. F of x is equals to 3x plus 5, then g of x is equals to 4x squared minus 3. Then we're going to write the quantity of 3x plus 5 d over x dx, the quantity of 4x squared. Then we're going to write the quantity of 3x plus 5 d over dx, the quantity of 4x squared minus 3 plus the quantity of 4x squared minus 3 d over dx, the quantity of 3x plus 5. There's dx in the equation because we're going to get the derivatives of the two, which the derivative of 4x squared minus 3 is 8x, and the derivative of 3x plus 5 is 3. Next, we're going to write it the quantity of 3x plus 5 times the quantity of 8x plus the quantity of 4x squared minus 3 times the quantity of 3. After that, we're going to multiply it to f of x and g of x. So what we're going to get is 24x squared because we're multiplied 3x to 8x plus 40x because of 5 multiplied by 8x plus 12x squared because we multiplied 4x squared to 3 minus 9 because of 3 multiplied by 3. Combine like terms and the final answer will be f prime of x is equals to 36 squared plus 40x minus 9.
For the last and final rule, let's have the quotient rule. For the formula of this rule, we have d over dx times the quantity of f of x over g of x is equals to g of x multiplied by f prime of x minus f of x times g prime of x over the quantity of g of x squared. So let's have an example for this. Let's say f of x is equals to 3x squared minus 2x over 2x plus 4. So the f of x here is 3x squared minus 2x, then the g of x here is the 2x plus 4. But first, let's get the derivatives of f of x and g of x. So f prime of x is equals to 6x minus 2 because of the power rule applied to 3x squared and 2x. Then the derivative of g prime of x is 2 because of the same rule applied. Then after that, we're going to use the FOIL method to distribute it. For the equation of this, we're just going to copy g of x, then write the answer of f prime of x, then copy the sign. Then after that, copy f of x times the answer of g prime of x, then write the over sign, and copy g of x, then put squared. FOIL g of x and f prime of x, which gives us 12x squared as a result of 2x times 6x minus 4x because of 2x times 2 plus 24x due to 4 multiplied by 6x. and then minus 8 because of 4 times 2. Then FOIL f of x and g prime of x, which will give us negative 6x squared because of 3x squared times 2, plus 4x as a result of 2x multiplied by 2, still over the equation of g of x squared. So for the final answer, we'll combine like terms, and it will give us f prime of x is equals to 6x squared because of 12x squared minus 6x squared, plus 24x minus 8. We'll just copy it since it doesn't have any similar terms, and we'll cancel both of the 4x since it's the same. Then we'll copy the equation of g of x squared. We hope you learned throughout the video. And again, we are Group 3 and thank you for watching and listening.